morning, good afternoon, everybody. Thank you for joining us. This is the Best Kept Secret at Autodesk. It is your Friday HSM Hangout. We have a very special guest today. We got Lawrence. He is an HSM user from Europe up in the Netherlands, and the guy just knows a ton of stuff. He's going to be covering a lot of really great content, tips, and tricks. So if you've been using the software and you want to get to that next level, this is the place to be. As always, a couple quick poll questions here. We always like to understand who we're talking to, what your experience level is. So first question, how long has everyone been using the HSM product line? This could be Inventor HSM, HSM Works for SolidWorks. It could be Fusion or cloud-based product. Let us know. Get your votes in. Faster you guys vote, the faster we get into the product demonstration and the tips and tricks. Awesome. Thanks for the votes. Lawrence, any thoughts? Look at this. So good distribution, 30% are brand new, 30% have a few months experience, and then 40% are actually somewhat experienced, been using it over 6 months. So you've got a good crowd today.
Yeah, looks good. There could be some users in that actually aren't even brand new and not using the HSM software yet, but seems good.
Awesome. Now I want to understand, specifically for those of you that maybe aren't using HSM, what are some of the CAM softwares you might be using today? So let us know. Get these votes in. All right. Thanks for voting so fast, everyone. Appreciate that. So wow, look at this, guys. 65% of our audience today is using the HSM platform. So 25% are other, and then a small distribution for some of our other competitors out there. I'd just like to remind everyone, this is a live Q&A. We've got technical experts on the line answering your chat questions as we're going through any of the content. If something doesn't make sense, shout out who you are. Tell us a little bit about your business. Let us know if you have specific questions. And even if we can't get those answered during the live broadcast, what we'll do is we go back and we always try and get those answered one-on-one the following week. So thank you for that. And then here, this will be the last poll question before I pass it over to Lawrence here. I want to understand what's your primary role. Are you the person at the shop that does everything? Are you strictly a machinist? Are you strictly a programmer? Do you work on the design and the engineering side of the house? Or are you a student skipping class to join us for the HSM Hangout? So let us know. Get your votes in. Awesome. You guys are voting so fast that we appreciate that. And wow, look at this. Good distribution. So 42% are the design engineer side. And so, that integration, that's really important. 6% are programming. 10% are students, that's awesome, and 35% are doing everything. So that's great. Hopefully the next hour will really help you out. That's all we have right now on the poll questions. Lawrence, thanks so much for joining us, man. Welcome to our Friday Hangout. I'm excited to see what you have going on.
All right. Hi, guys. Indeed, I'm from the Netherlands. So for me, it's 6 o'clock right now, and not just in the morning like it is for most of you. And I'll try and teach you some of my tricks that I've got and tell you a little about who I am and what we're doing. So let me show you the plan for today. So yeah, first about me, the company, 3D Tech Drop, who we are, what we do, where we are located. Well, I've told you that already. And after that, I've got some specific things about slots, the extension distance, 3D versus 2D operations. Something I'm really passionate about is the interactive post-processors, since that can help a lot of people out with easy things, which seem hard in the beginning. The use of templates, since people tend to neglect them in the software, which I understand, but they're really useful in turning, and especially in Inventor HSM. A little bit about setting defaults. There are a lot of videos about this, but it's a really important part of the use of the software. And after that, I've got some tips on how to get support and how to find your way on the forum. So here on the left you see me, the guy with the beard. I'm actually controlling our own KUKA robot. This will be used to load pieces into one of our machines. We thought about buying a whole package that you can just put behind a machine and have it work, but we're kind of the guys that actually want to do everything ourselves and control everything, so we're doing this all by ourselves, and we'll have a whole cell for this by our own design. The guy on the right is Jasper Wijnschenk. He's my brother, boss, and the guy I see more often than my own girlfriend. He founded the company in 2008, so it's on the way for quite some time now. We're located in the Netherlands, quite near Amsterdam actually. Not that it's really important, since everything in the Netherlands is quite near Amsterdam if you look at it compared to the USA. We're working with 5 guys in the shop floor right now. Jasper isn't that much on the shop floor anymore, since getting work ready for 5 guys takes quite some time, so he's doing that mostly right now. I started with the company a little later, since the company first started as a 3D technical drawing company, so like modeling stuff for people. And it was only after 2 years that Jasper bought his first machines. And after some CNC equipment came into the shop, I was drawn to it, and that's when I started on the company. And something most of you already know, when we moved all of HSM Works into the Autodesk system and platform and really made it part of the HSM team, which we've got Inventor HSM now and Fusion 360. We also get things like expert elites for the forums, etc. And I was the first one to become an expert elite. We've got quite some now, and it's a good thing if you ask me, because there's a lot of people that know at least as much as I do, and I'm going to try and teach you some of that now. This is the first shop my brother rented. You can see that a whole lot of stuff is still manual here. So the first CNC machine here on the left was a milling machine, which we programmed at the machine. And for us it's good to look back at this, because it feels a long time ago, and it is a long time ago, but on the other hand, actually we've come far in a very short amount of time. So this is our next shop. If you look at the bottom left picture, it's the first blue overhead door you see. That's where we were located. On the picture itself you see our 3-axis Dozan milling machine being lifted, and this was a big day for us, and we took pictures of everything, but I think this shows most of it. In the top left corner is how it was when it was finished, just after everything was put down and was working. But to get to that point, we started with the picture in the top right. When every machine was put in the shop, we found that the floor was actually moving when you drove the forklift around. So that didn't turn out to be a very good plan to move the machines in. So we put them back and drilled some holes to support the floor. And that's when things really kicked off. We also bought a turning machine, which you see in the picture on the left as well. Not a very good picture of that actually, but that was brand new when it came here in the shop. And the bottom right, this picture shows when Al, Achim, Stefan Kraus. He's one of the guys responsible for CAM in Europe, and myself, my brother, and the Dutch reseller. This was when Al visited our shop, and some parts there as well. So if you're active on the forum, you might get a visit from Al and the guys, especially Achim Hirk is doing some changes to the post-processors. Is one of my my hobbies, which I do when I'm sitting on the couch in the evening. So it's a guy I speak to a lot through the email. So he wanted to see our shop, and this was one of those visits. Now we come to where we are located right now. This is the building you see in the first picture. The rest is just to show that we wanted to step things up a little and get a nice floor, get everything cleaned up always. This was a video I posted on Instagram to show all the machines were warming up with the green lights you see. And yeah, it was a Monday morning after the weekend. We were starting things up, and we try and keep it like this, cleaned up and ready to show for everyone all the time, but that's quite hard, as you might expect in a shop. I also wanted to show you a little on what kind of stuff we made. A lot of you might have already seen these parts, which are made for the Fusion Camp Challenge. They wanted a medallion, so that's what we made. Everyone made some little changes, so I made mine so I could cut it 5 axis. Since Rob Lockwood already did quite a serious webinar on that, I will not focus too much on things like that, but more on the easier things. This is an actual cylinder head that some of you might have also seen on Instagram. If I can't share a picture of the part, I will, but usually I can't, so I was real happy with this this project. It's gonna be put in a top fuel drag race motorbike, and it's, even for us, a very cool part to make. Then on the left top here we see a camshaft that we not only turned with HSM Works on our lathe, but also pre-machined it so the grinding wouldn't take as long. This depends on a couple of things, if we do this or if we just leave it for it to be grinded afterwards. On the top right you see something that we've actually developed together with a company nearby. These are parts to tow trucks, and with a truck I mean an actual truck. Here in Europe all trucks are, they need to have some kind of system which you can pull them out of a ditch with, and the company that does the towing actually thought, well, we could also lift those trucks with it, and we designed the system for them so they could lift all different kind of trucks, since they all have a different way to pick them up. And these are the finished parts you see here for DAF trucks. And on the left we've got an inlet manifold, which I machined for some cross buggy with the Hayabusa engine on there. And in the bottom there's, on the right, there's a mold which they use for getting fabric in the right shape for some kind of chair. I'm not actually sure exactly anymore. So the things we make differ a lot. The ones that I can show you are usually mainly motorsport items. You might find that weird, but they usually do anything to get a discount. So if you say, I will make it for you for a slightly lower price, but I want to be able to show it to the world, they tend to say yes quite easily, whereas others are way more scared of their products being shown. So that's why you see a lot of motorsport items here. But we make a ton of different stuff as well, which some of that you see here at the bottom right hand corner. That's totally not motorsport. It's part for the offshore. What they're going to do, I've got no clue, but they wanted it like this, so we made it. On the top left corner, there's a part that's on a wheel gun to tighten a wheel nut. And these are not these actual ones, but the ones we've made have actually been shipped to Le Mans, so they could be used during the 24 hours series. There's no way for me to prove that it actually happened, but I guess so, since they bought them. The top right hand corner is for the cylinder head, and the top of the bottom left corner is something we made from the anodized aluminium part into the titanium part you see on the right hand side. The trick was to keep the weight down on the titanium part, but it was a lot stronger, of course. So since the aluminium part cracked, we needed a stronger version, and that's what we did right there for the customer. But in the end, it's not about what you make or what you do, but having fun. So you see me here on the left, and one of my colleagues, Mark, here on the right, in the old shop, singing when the radio was on, and it really shows what we try and do. It's not all about work, but it's about having fun while doing it. So we actually all like to go to work in the morning. Of course, there are days where it's hard to get up, but it's more than just work for us usually. So, on to the actual stuff that most of you came here for. So, let's do it. All right. Everyone's gonna see slots when they start making parts, and they tend to change a lot for what kind of products you're making. But I try to pick some on how we could program them. Of course, there's this slotting operation we've got, and we'll select the tool. I've tested it before, so that's why the tool's already the correct one. We just hit generate, and it should be good to go. This is an easy one, most people will understand, and I think it's just a very good operation. Now, if we want to make this curved slot, you might think, is this going to work? Of course it is. So we're going to try and make that one. The selections are a little different between HSM Works and Inventor HSM, but usually the workflow is kind of the same. So what you can do here in HSM Works, which I just did, and you can also do in Inventor HSM, I believe, is use a way to duplicate it, which is got a shortcut here, and that way you can make the same operation just again, and usually I have to change the selections and have a ready operation. From here on, the slots get a little more tricky. We've got an open one right here, and this is something that requires some knowledge to create well. Some users might say, I'm going to use a 2D contour for this. You can, because that's the easiest way to hack yourself to the correct toolpath. But actually, the slotting operation is much smarter than you might expect. And what happens here with the selection, if you take this one away, we'll turn these two off, and we'll select this one edge, the one over here, and the one over here. You'll see these 3 lines that I clicked have gotten a little thicker, and there's a small blue line here on the end of the slot, and it shows how it closed the slot for us. If we press the green button right now, the slot will actually generate and will understand that it's an open slot, and it can just plunge right in, cut to the end, and come back up again on the other side. So a real easy way to get this open slot. It also works in Inventor right now, but there's a small catch, since if you regenerate it afterwards, the system will go haywire. So that has been sent in. There is a ticket for this in the system, and the development guys will fix it. Don't expect this to be tomorrow, but it could be. It also could take some time. Then these 3 slots we've seen right now are quite easy also to program, and they're also easy to do in your mind. But these ones, this one and this one, are a little more tricky to get right. Here we are going to use a 2D contour, and still the same tool, that's all fine. We're going to click one of those edges. If we do that right now, we get the full slot, which we don't need, and we've got this edge selected right now. To get this right, we need to turn the lead in and lead out off, or at least take this 90 degrees off. So the lead in and lead out will not cut into our actual part. Now if we do this, the actual cutting path looks quite good, but we have a problem with the tool plunging into the stock we've got, because it doesn't move out of the stock far enough before it starts the cutting. Again, there's a whole lot of ways of getting this right. We can extend the lead in this case, to 10 for example, and as it shows you right now, if we simulate this, you can see the tool starts outside of the part, cuts right in, leaves the part before it comes up. We can, but this gets a little tricky when we are not sure how much stock is left on this side. So we're going to put this back to its normal value, and we're going to turn on the stock contours. If we do this, we see this orange box which shows us the stock that has been set up in our job. This is called a job in HSM Works and a setup in Inventor HSM, but it's the same thing. This orange box is now shown here. We can also override it when we do a selection here. That would mean this is our stock, but usually your orange box will be fine. If we hit the green button right now, this should all work fine, since we see now the actual cutting move is extended beyond the whole stock, and it will plunge there and come out. You see that it made more of an extension right here than on the other side. That's due to there being more stock on this side than on the other one. For now, this seems pretty easy and straightforward. Now we come to the last one, and this one is much more tricky than you might actually think. If we take a 2D contour here, and if we select this edge, we can also select the end of this line to make it stop the selection. You could think, well, if we turn on the stock contours again, it should make a fine path. Well, by the looks of it, it's pretty good. Only if we will simulate it now, we will see that it plunges outside, it will cut straight in and come to the other side. This looks okay, but if we do the comparison right now, we actually see that it has left some stock here in the corners. If I'm going too fast with this, please tell me this, because for me this is really easy and I do this every day. But you can compare the current stock that has been machined to the actual model we've got, which is what I'm doing right here. And gray is what is actually the same as the model. Blue is where there's too much stock left still, and red is where you've got into the model. So we see now we've left these corners right here. This is due to the tool running around this corner right here, and we can do a couple of things. The easiest one probably is to not select the inner edge but the outer one. And if we do this and we simulate it, you will see that now actually the corners are just gray like we want them, and the inside of this slot is still good as well. So with that in mind, it's usually easier to do just this. Well, we could have also set the rolling around the corners off, which we can do right here. Roll around corner and we say keep sharp corner. If we do this, we should get the same kind of path that allows us to cut this slot in one go. If we check on that, because you can also question me on if I'm right, no problem. And as you see, this is good as well. Sometimes you see a little discoloration here of it being red, but that's due to the quality of our simulation and the comparison settings, which I will not go into, but you can fiddle around with them yourself. That's it for slots from me. I'm not sure if any of the guys want to interrupt me at this point.
The only thing I'll say, Lawrence, I like how you showed how you can use stock. Obviously, that's applicable to all of the 2D operations, but it's an often thing that's missed is adding the stock contours in to affect your 2D toolpath, so I'm glad you brought that up.
All right. As I think the next thing, I didn't put it back on here again, but I'm going to explain something about the extension we can also do, which I showed you before here as well. But there's something funny about this. We can extend the toolpath if we want to. So let me create a new job. And set, this is my top. Yeah. All right. Automatically it will set this new job we made to the default one, which we're going to put operations in, which is very convenient. It's one of the things that you don't actually see, but it's been really thought through by the development team. So let me show what I'm on about here. What we can actually just do is create some kind of open pocket with the 2D contour here, and create some roughing passes as well. Let me first give in 10, and we can see what happens. It will just create this toolpath around the edge that I selected. Since to keep offsetting this part, we get these round corners here at the bottom. This is good for the actual cutting. It might look weird if you're not really used to seeing a machine run or programming, but this is actually how you want the path to look if you are using it as an open pocket. Again, here we see that the tool will be plunging into our stock. If I select the job right now, you'll see this yellow box, and that's actually the stock we've given it. If we look at where the toolpath is at this very moment, this is the center of the tool that's being programmed, so we know it's going to plunge right into the stock. We can simulate that as well. And we see it will plunge straight in. Since this is not what we want, we are going to extend the toolpath. To do this, we've got here an end extension box. It will extend the toolpath like it says, tangent to the actual move that it did at last. So if we would give in here at least half the diameter of the tool, we should be good. So the tool is 10 millimeters, so I'm going to fill in 6. I'm sorry for you guys that I'm doing this in millimeters, but that is my world, so that's much easier for me. As you can see now, this blue line has been extended to outside of the part and outside of the stock, which we should be able to see clearly when we're doing this simulation. As I know this is now doing something like a full slot, this is not my roughing operation. I'm just trying to show you how we could do this kind of open pocket. To do this correctly, you're going to say, yeah, but we got to machine this whole face. Now we can just say, all right, we need a lot more passes. Yeah, we give this in 20. It will give me 20 passes. This will also show you that we're cutting way too much here because it's all going to be just air. Well, it's actually going there, it's just going to cut air, which you should be able to see here. It's just moving in the air, and that's something we don't want even when we're not programming an adaptive toolpath. We never want air cuts. So what is going to make life a whole lot easier for us is turning on the stock contours again. It's going to show you the orange box again, which is exactly the stock we've got. So this is good. To be sure, we are going to extend all the passes over the whole part here. What I usually do is just fill in something like 100. My computer is a little slow since we've got the GoToMeeting open and Inventor HSM open, SolidWorks open, but usually this is not really hard on your computer and the calculation time is real short, so you don't have to be scared that you're putting in too many. As you see now, these cutting passes are cut before they start cutting air. This is something we would want in theory. Now the thing comes that in the machine this block might actually not be exactly as we've defined in our system. To prepare for that, we might say we want to extend the toolpath just like we did before, just outside of the part a little more, so we're sure it will plunge outside of the part. Now you will see that I've left here this extension distance in the end. But from the simulation we can, or the other simulation, I can show you that it's not actually moving more than 6 millimeters, that's extra 6 millimeters out of the part, just to be sure for this clearance that I would want. This is because the extension distance you see here at this point is extending the passes, but these passes are still allowed to be cut by the stock contour, since it would say to the passes like you're going outside of the stock, so there's no need for this extension. If we put this one back to 0 or leave it at whatever you want, it doesn't really matter. There's another box right here which has got no one's attention usually, but it's got a lot of power. If you put the 10 millimeters in here, you'll see that the path actually is extended beyond the given stock contours we've got before. This is the one with the extension distance in the first tab, and this is the one in the cutting passes tab. This is something that it took me quite a while to find out, but it's really useful when you're cutting like pre-cut stock on a laser or a plasma cutting machine, or even get a mold for something. So quite easy use, 2D paths, but that's a good thing about 2D paths. You can manipulate them in any way you want. From here, as we see in my fantastic PowerPoint, we're going to do something about 3D versus 2D operations. Let me move this job up for you. So we're making this one the default folder, and from here on all the toolpaths I make are going to be put in that job or setup. This looks like a real easy part. So what I would usually do is something like this, is face it off. Let's see if we can find some bigger cutter than this, which I've got in here. No, that's a ball and mill, like that. All right. We'll face the top off, and from here on we want to actual machine this side. Since it is such an easy part, we might think that the easiest way to do this is a 2D adaptive operation. Of course we can, there is no problem. We select this outside box of the box we've got here, and after the stock contours turn on automatically, disable the machine cavities, and I believe we should be ready to go. As you can see, actually yes, we've pre-machined the outside right now. I didn't bother really much going into the cutting parameters, since 25 millimeter tool will be able to cut 30 millimeters deep, and the 40% step over usually is a good guess if you're not sure on where to start, if you ask me, but that might be different for everyone. The trick is now we also got to machine the inside. We can duplicate this and start cutting the inside. The only difference we do is we turn on machine cavity selection, select the inside, and we have pre-machined the inside. The machine will automatically know that we're cutting into the inside of the part, so it will have to use a helix to go in. You can overrule this, but in 9 out of 10 cases this is the kind of entry you would want. After this we can finish the path with something we did before, like the 2D contour, and finish this floor, use another 2D contour to finish the side, and the same for this inside. So let us do that real quick. Also, if you are actually an HSM Works user, please look at the way I click the lines and boundaries. If I click on the end of a line, you'll see the arrow being on the inside of the square. If I click on the beginning, it will be on the outside. So all the clicks on which side of a line are intentional to get this right. Turn the stock contours on. Usually I would want to leave something on the side in this case, and not on the floor, but on the side, so I can fully finish the whole wall with another toolpath. Turn on the roughing passes, make it 10 wide. We've got a finishing pass here. We can also make that the same as the roughing passes. And like this, we've finished the floor here. What we could actually do here in this case is use the same for the inside, but it will plunge into the last bit of stock that we've left with the 2D adaptive. So for there, I would suggest going for a pocket routine with actually the same kind of settings. Those don't really matter in this case since we're only finishing just the floor. So that should actually be pretty easy and good. It is gonna start totally at the bottom at the top of this stock. That's how it's usually set. We can set this top to 0.5 from here because that's what I left on the floor with the 2D adaptive. That's a standard settings, so you can usually expect something like that. And with this, we've got the floors covered, and now we can start finishing the side walls. Can do 2 clicks. We've got this one. You can change the cutter compensation type you want at this moment, and if you want to do multiple finishing passes or repeat the finishing pass, this is something I do quite often when I need to have a perfect size and finish on the side wall. I repeat the finishing pass since the first time usually gives you some kind of deflection on the tool. So for getting the size quite right, it's usually quite easy to use the repeat finishing pass. From here on, we have actually machined this side with 2D operations how you would want it. Let us simulate it. That was a little quick. There are some buttons here in the simulation, like I want to generate the stock until the next operation, because the facing is not something we want to look at for another hour. So we just click the button, you see it's finished, and then we can start it again by looking at the next operation. This is the 2D adaptive. Like I said, we didn't really bother looking at the cutting parameters, etc., but the operation itself usually knows what's best for you, so to speak. So this should be good. This is then the third operation we're doing to clear out the inside pocket with the same parameters, so don't shoot me for those. Now we're finishing the outside. Look at how much travel we've got of the tool, which is all retractions and airtime we in the end wouldn't want. So we'll need to improve on that if we want to actually sell this part to a customer, which we're not going to, but it would be nice actually to have something this easy for a change. Now we're cutting the side walls, or actually finishing them. And alright, this is good, and this is how most people start using Inventor HSM or HSM Works. But I'm not real sure if this is the way to go if you're new to programming this. We can do a whole lot of manipulating to 2D toolpaths, but if you ask me, the 3D toolpaths are a lot easier to get right. Since we want this inside and outside to be machined exactly the same way with the same kind of tool, we're going to use one 3D adaptive to get this right. I'm copying the facing because I still want my part faced, and for the first side of the part, facing is usually a good way to get it to this correct height. From here on we go to the 3D adaptive, and we left the cutting parameters in the original one. We're going to do this here as well. Only thing is that now it doesn't know till what height we would want to machine this. So if we click generate, it's going to go to the bottom of the model, which is the usual setting. In this case we don't want it, so we're going to put it here. And if we click generate now, we've done one click versus how many we've done before, and we're machining this part. Now there's one thing that the 3D adaptive will automatically set a cutting depth. This is something that on my own computer at work I've got all kinds of defaults for, with 7/8 of the flute length, for example. I haven't got that system here, but we'll put this now to 30, and since this is 30 long, we'll put it at 35, and should also make one pass like we've done in the 2D adaptive. You can see it being generated here. It takes a little longer to generate in this case, since it also generates the inside pocket for us. So with a minimum amount of clicks, we've actually created the same kind of toolpath as we would have with these two 2D operations. Now we see here is the finishing that we did, and this means that I've got to make two operations, one pocket from the inside and some sort of open pocket on the outside. There's a horizontal toolpath in the 3D zone, and this will actually finish all flats, so to speak. To get this right, we wouldn't want to set the bottom again, because we don't want it to cut this side here, and we don't want to cut the top anymore, since we've already faced this off. Select the top, go a little beneath that, and from here on the system will take it from there. It will make the toolpath, finish it. It will also helix in here. You only see a very small helix, since I tell it there's only a very little amount of stock left, and this is something you can control here on the linking tab, how much clearance height you want it to have before it starts cutting, and 1.05 in this case is usually enough for me, since we leave 0.5 as default, and that's something I use nearly every day. From here on I would usually use the 2D contour to finish this part up, since that's got the compensation type you can select, so we can just copy it to this one, and we've created the same side. Only, if you ask me, with a lot less knowledge of actually how the program works, or actually programming knowledge, the only thing you actually have to do for the system is set the heights you want it to, versus selecting all the contours it needs to cut and overriding things like the model. So even if it looks like a 2D part, I would suggest going 3D for the roughing, and mostly for finishing as well, except for side walls. Yeah, go away. Since that's something you want to keep the size, something you want to control on the machine usually, with the wear settings on the machine. Guys, any questions I should know about?
Hey, Lawrence, thanks for that overview. Let's check the questions. If anyone has a question, please submit them. I know we have our technical experts. Wayne has hopped on here. We've got Al on there as well, answering questions on the fly. Al, Wayne, any questions that you want to maybe bring to the attention of the collective group that we might have answered one-on-one so far?
Rob Lockwood would like to know how you call that a beard.
Yeah, well, it's a good question, Rob. Actually, it's much longer right now, but on the other hand, you don't want to see me because I'm sitting in the same room as where my girlfriend does the laundry, so not ready to share that.
Any serious questions, Al, that will bring value to our community? Okay, guys, so this is your chance. So get those questions in if anything is...
So there was a good question that we kind of addressed from John Saunders, who actually is another guy that did a webinar before. So maybe I'll just add that comment. It's cool to see how the community comes together, and so many users have done webinars or joining and watching. It was cool to see how your company has grown with us, Lawrence. But yeah, the question is, why do you use 2D contour, 2D pocket over horizontal? And I gave a little explanation over more control of the toolpath, but your perspective on this one would be good too.
This was when I was explaining how we do this 2D way, and yeah, you could use the horizontal like I did afterwards, which I would usually do since the horizontal is very easy to program. And what I mean with that is I select the heights between which flats it should machine, and from there on I don't care about it anymore. But one thing that the horizontal also does is create an extra pass on the outside, for example. It's usually one of the last passes you see in the operation, and that is one that cuts air in many people's eyes, like this pass you see right here. And what you could actually do is replace this horizontal on the outside with a 2D pocket, which might be better if you're doing like real big series of parts, like more than 100 you need at least for this to be something to consider, if you ask me, since it's much easier to program, and the more easy you make life for yourself when doing the programming, the quicker you're at the machine and producing these parts. And if something changes to the part, the 3D operations automatically change with you, whereas the selections of a 2D operation might not do. So that's kind of...
So I think we have a great question here from Scott Moyse in New Zealand. I wonder what time of day it is for him now. He's asking, what are your favorite 3 power user shortcuts?
This is a hard one if you ask me, because
give us your top 10. If you're having trouble boiling it down to 3, then I think everybody...
No, the question... No, for me it's more, what do you mean with shortcuts? Do you mean like keyboard shortcuts, or are you looking for...
What are the things that you feel like, because you've been using this product 6+ years, make you faster? Maybe things like the shift key, but what are things that... and it's hard because you do it every day, but things that make you faster at what you do using the software that might not be immediately obvious to the users.
One of those things actually is copying selection from one operation to another. How I'm going to show you this is if I create another 2D contour right here, and it's going to show you that we've clicked this, but we can actually copy all of this to all the geometry selections we've done in 2D contour 8 to number 9. and no, go away. How we do this is a little tricky at first, but it's real convenient when you do it afterwards, and that is using the Alt key and the Shift key. And if you then press those two and move it to the other one, it's going to ask you this: do you want to copy all compatible geometry from one to another? This also works for 3D operations that have the same kind of boxes. So if you look at an adaptive clearing right here, it has machining boundary and stock contours. If both of those are in another operation as well, like for example the pocket clearing, it will copy both of them. If only, for example, machining boundary is available in the other one, it will only copy the machining boundary. So that's what it means with the compatible geometry.
So I'm glad you brought that one up. Of course, then the question started blowing up for me, when are we going to get that in Fusion and Inventor? And I'm glad you did bring it up, and we do need to get it in the other two products.
Yeah, this is especially one that Scott himself and myself have been on about on the forum, that we need this, but we also know that you guys are usually quite busy with implementing a whole lot of stuff in Inventor, HSM, and Fusion, and this is one of those things that have grown with the system and now work
So
in
that's
HSM
Works. People probably don't want to know it. Then you can drag and drop, and HSM Works you can drag and drop an operation onto a surface and have a copy geometry too. So that's along the same lines as this functionality.
Yeah. Something else that indeed we've got with dragging and dropping stuff is copying a tool. We can copy this Diameter 10 tool from this toolpath to the Contour 8 right here. Something I use quite often, especially when I work on parts that are machined on different machines at some points. Then I just duplicate the whole setup and start copying tools that are different in each machine and change little things there. This gives me the opportunity to quickly change tools as well. If I found on the machine that for this 2D contour it works, it will probably do for the other one as well. Just copy it over and say,
we're running out on time here, but Lonnie, another one of our common users on the forum, is asking about how you do that drag and drop of selection. So can you select that inner pocket and do a drag and drop of an operation just to show how that works?
This one? What do you mean in this case? You mean like
am I
this?
teaching you something too? Drag and drop a contour out to that.
Yeah, I like this. Only trick is that we're doing this with surfaces here, and I'm not a big fan of using surface selection with 2D operations, but as long as it's this bottom surface, it will be all right. But you can't use 2D operations with sidewalls, for example. This is a common mistake, and since we're running into this now as well, I will show that with 2D operations, we can select indeed the bottom surface, which you can see here is now phase 2, and we can select an edge. But if we do this, there a whole lot of stuff might go wrong, and probably will. See, I can't even reverse it at this moment. So this is something that, if you can look at it right now, this is not the toolpath we want, and this is something that a lot of people run into. So this is good to get out that we can only use bottom surfaces for these 2D operations or 2D lines.
Yeah, and it will do tool orientation too. So if it's a pocket from a different face, it will do that.
Great. Well, thank you so much, everyone, for joining us today. Lawrence, we could go on for hours. You're obviously an amazing power user, so thank you for coming and demonstrating to our audience Exactly, some tips and tricks, and it was really cool to see how your business has grown thanks to the HSM software.
Yeah, all right. It was fun to be here. It went a lot quicker than I would have expected, to be honest. So, yeah, we might need another session somewhere later to finish up on where we left right now.
Perfect. Well, we can certainly explore that opportunity. Now, if everyone can see my screen, I just want to point out a couple of resources here. In addition to our awesome reseller network that you guys are welcome to work with, and our team here that supports Autodesk, so specifically Matt Nichols, Wayne Griffenberg, Tim Paul, Al, everyone that makes this sort of great stuff happen, you have the Autodesk Knowledge Network at your disposal. So this is a really great resource. If you have interest in any products here, you can come in and select that, and all the information that you need is at your fingertips. The other place that I'd want to bring everyone's attention to is our post section. So we ship over 100 post processors for free with all of our products here on the HSM product line. You can go to cam.autodesk.com/post and search for those. You can also access that in the software. And then for those of us that have friends and family that are students or educators, the Autodesk Education Program gives free software to students and educators. So please take advantage of that. If you know a student, let them know. They're paying for a lot of products right now, and they can get a lot of our stuff for free. And then for those of you that are interested in 3D printing, additive manufacturing, I'd like to point your attention to our NetFab product from Autodesk, which is an end-to-end solution for your additive manufacturing needs. And if you have any interest in that as well, please go out to netfab.com and download your free trial and get in touch with your contact at Autodesk to learn more about how you guys can also branch out into additive
Jordan,
manufacturing.
you cannot let Lawrence, the granddaddy master of the forums, give a presentation and not draw attention to the HSM forum. So why don't we make sure everybody knows about it.
The last thing that we're about to do here. So you guys can go to our forum, really easy to find from pretty much anywhere that you're at. Just look for forum, and this will load up here real quick. And then it's important to note this is one of the most active forums out there for CNC machining on the internet. And what's really cool about it is that we have people like Lawrence and Al actively participating and helping out in answering our customers' questions. So if you've got a question, come on here. Chances are somebody's already asked it, and there's an answer waiting for you. And if there isn't, you can also submit that. If you've got a great idea for the product line itself, we have the Idea Station, which is something that we just launched, so you can upvote your ideas and contribute and actually, get inside of Al's head and influence the path of the product. So really great. You can see here Paul Klaus, one of our Autodesk technical specialists and good friend of mine, is contributing. So take advantage. And there's Rob Lockwood. And next week, we've got Wayne Griffenberg. He's going to be doing an awesome presentation on containing 3D toolpaths. So please join us for that. Same place, same time. Al, Lawrence, Tim, Matt, Wayne, everybody. Thank you so much. We'll see everybody next week. Same place, same time. Have a great weekend.